I think the last thing standing in the way of our int vector class being a fully functional replacement for an std vector of int in the context of that we were using vectors earlier in the course, so in our first few weeks of examples, the last remaining thing is the ability to do this. So we've written pushback, we've written .at, the vector can grow and shrink as needed, we can pass it by constant reference, we can even now initialize it with initializer lists to be constructed already containing a bunch of elements, but one thing we were doing from day one was iterating over our vectors with for each loops, a very nice abstraction that avoids us having to worry about indices on our sequence, which is great. So we'll just hope for the best and press enter here and try compiling this. And the compiler's not happy. It is really not happy. If we scroll up though, we might be able to try and figure out what we need to do to make this work. So it's giving us an error on line 115. So there's some stuff below this that's commented out, but clearly line 115 is the first place the compiler runs into trouble. It points at v1, but its complaint is a little bit weird. So it says error. Begin was not declared in this scope. Begin. Where have I heard that before? If we scroll through it, it does the usual thing where it tries to show us all the other stuff it tried. And then it says, also, by the way, error. End was not declared in this scope. Begin and end. Where have we heard those words before? And it turns out, in fact, that a for each loop is actually just a thinly veiled use of iterators. When you write a for each loop, what the compiler really wants to see is, it reads the for each loop as something like this. v1, it creates an iterator, it advances the iterator until it's equal to v1.end, and at each step it does this. It uses plus plus on the left. That's going to be significant in a minute for the sake of us saving some work. And then I suppose you could argue that it does something like auto x equals star iter. So when you write a for each loop that says for auto x in v1, you're really getting something that looks like this. The compiler tries to translate it like this. How it gets begin is a little bit more complicated than this. So there are other ways of providing a begin function than just v1.begin, but we're going to work with that. So when you use for each loops, you're using iterators. One more reason that C++11 and modern C++ dialects are so great is that iterators are pretty clunky, and we do not want to have had to learn them in the first week of class. We did eventually learn them, and they were clunky when we learned them, but it was great to put them off. It was great to have an alternative for the basic case of iteration where we were using the natural ordering of the type. I want that for my vectors. But before I can get a for each loop, I need iterators. And iterators are a little bit complicated, so we're going to spend 2 videos on it. Before I work on the more general iteration case, I want to talk about this. I want to create the basic appearance of an iterator. So I've got these operations that I think model, I guess, a good first step for when a sort of a basic iterator over a vector might need. So I can create an iterator, auto iter1. We're going to use the type auto for these iterators because we know that the type of an iterator is sort of complicated. And I'm supposed to have a function called begin that returns an iterator pointing to the very first element of the vector. So conceptually, on the vector v1, which I've defined up here, if I make iter1, just to map out the operations that I want to happen, here's iter1. I can call begin to have it positioned at the very first element of the sequence. Then I'm going to print out the first element, which should be 6. Then I'm going to walk along. So plus plus iter is walk the iterator along by 1. We might be used to writing something instead like iter plus plus. We should understand that these two things, plus plus iter and iter plus plus, have similar interpretations. For our purposes, both of them do move the iterator along by 1. Because the for each loop, when the compiler sees a for each loop, it reads this. I'm going to focus on this operation. Although we could also define iter1 plus plus. They are separate things. So I move it along by 1, I print out 10, I then move it along again and I print out 17, and then I move the iterator backwards and it points to 10 again. So I should see 6, 10, 17, and then 10 if I print these things out. And then down here, I try using iterators to modify things. So I use star iter above to read an element. Here I use star iter to modify the element. Just like the .at function, we can sort of see that this is going to require the iterator to maybe return a reference to something, because the result of star iter should be something I can assign to. So my goal in this video is to write the most basic iterator that can just do these things. We'll talk in the next video about the iteration case, which is where I also have to define the v1.end and the ability to know when an iterator has reached the end. And more generally, this idea that an iterator can become invalid. For today, for this video, all I care about is making a valid iterator, moving it along in valid steps, and accessing or modifying elements at each step. How do we detect whether the iterator has become invalid? That's a question for the next video. So fundamentally, what I really need is a function .begin. That is the beginning of our process. Now, what the function returns is going to lead us into the next part. So I'm going to scroll up, and we're going to get into our vector class. I want .begin to be public. So here's the end of our existing list of public members. I would like a function called begin that returns something, an iterator, I guess. I'm not going to have it be a constant member function because at the moment I don't want to differentiate between iterators that allow me to modify and iterators that don't. That is something I'm not going to get to. It is true though that most iterable classes like vectors and lists actually define multiple kinds of iterators, because when you're working with a constant vector versus a non-constant vector, what you're allowed to do with each element is different, and that percolates all the way through to things like what type do your iterators have? Is it a constant type of iterator or not? And we're not going to worry about that, but we have seen already the adaptations we can make to allow things to be safe for constant contexts. You would do something with iterators. So the issue here is to define a function called .begin, I have to create an iterator object positioned at, positioned at the first element of the vector. Okay, and then I return that iterator object. So wait, what's an iterator object? Let's go back down to main and see how we're using it. The thing I get back from v1.begin, what can I do with it? Well, I can use the ++ operator, I can use the star operator, and I guess I could make a second iterator later that's independent. It seems to me then as if what comes back from .begin has to be its own object. I can't just return an int or a float or something. There are ways to make certain non-object types behave like iterators, but I have an ulterior motive in this video, and that is to make it so you could write iterators for things that aren't vectors, like lists or arbitrary types. So what I want to return here is some actual object, an object that has operators defined on it. So I'm going to call it iterator. Okay. And I'm going to define my own class to represent what an iterator is. I'm defining this class inside of my vector object. So the full name of this class is int vector : iterator. But when I'm inside the int vector class, I'm allowed to use anything else inside the class by its I guess on a first name basis. So I can just call it iterator in here. The type of this object outside of int vector, so in main, the type would be int vector : iterator. Recalling that the : notation is what we use to indicate that we're going inside of some namespace like a class to retrieve a name. So what I want to do is create an iterator positioned at a particular element of my vector. And I want the iterator to have its own identity. I want it to be able to move along on its own. So I want the iterator to keep track of where it is in my sequence. The iterator, like the vector, will have public and private stuff. And so one public thing it's going to have is a constructor. And so then the questions are, what does the iterator need to function? So here's a vector, 6, 10, and 17. Here is my iterator. And we know all semester we've been using the abstraction of a pointer when we refer to iterators. But really, the iterator is an object that pretends to be a pointer. We saw in a previous week that we made an object that pretends to be a number. So these fraction objects, which were actually objects with behavior, but we could use operators to make them behave just like a regular numerical value. We're going to do the same thing with our iterator object here. And so I want the iterator to impersonate a sort of pointer to an element of the sequence. To do that, what do I need? Well, I need to know which sequence I'm referring to. So I have to keep track of what vector is this iterator a part of. So I'm going to call this vec. And so inside of every iterator object, there will be a reference to some vector that the iterator goes with. Because I could have lots of iterators referring to lots of different vectors over time. But one iterator only ever refers to one vector. Notice how this is being stored by reference. So when I create an iterator, I have to tell it, hey, what int vector object is it associated with? What is the associated vector? The other thing I want to do when I create the iterator is to say, what index is the iterator positioned at? So the iterator I have drawn on the screen is positioned at index 0. But in general, an iterator can be positioned just about anywhere. It can be positioned here, it could be positioned at the end of the vector, it could even be positioned at some invalid location past the end. When I create the iterator, I need to know where is it positioned. Actually, I guess I should use unsigned int for that. The iterator will also internally store what index do I refer to. And so when I construct the iterator, I will use some notation sort of like this. I will initialize my reference vec to be the associated vector that somebody provided from outside. I will initialize the internally stored index of the iterator to be the initial index that you provided. And I think that's the end of the constructor. The iterator doesn't need much more to get started. I can create a new iterator. For some reason, it's not liking my indentation. I can create a new iterator with just those two pieces of information. What vector does this go with? And what index do you want me to start on? And actually, I now have enough to write the begin function. So I could say, well, the begin function will be make a new iterator object, and it'll be positioned at, let's see, this vector, the current vector, so star this. Remember that the name this by itself would have type int vector star, a pointer to a vector. I want the actual vector, so I have to do star this. Another case of that annoying notation, that star this notation. Make a new iterator associated with the current vector positioned at index 0. That is what .begin is supposed to do. And I guess I'll call it result. And then I'll just return that. And the compiler gives us a free copy operation that allows us to copy iterators. It should be sufficient because the shallow copy is enough. If I make a copy of an iterator, I'm referring to the same vector at the same index. Okay, but I'm not done. I mean, if I try compiling this, we can see that I'm not done because it's going to give me a bunch of errors about things. Let's see. I guess it's still complaining that there's no member called .begin. Let's scroll down and make sure that I save the file properly. So here it's complaining on line number 136 about that. If I scroll in, yeah, that's a good point. So the compiler's giving me an error that isn't actually related to .begin. It's saying, sorry, on line 82, you're saying iterator, but I've never heard of an iterator before, which is actually a very good complaint. The reason is because I haven't defined the iterator type yet. So I'll define that here, and then I'll define .begin below it. And we'll see if the compiler sort of stops complaining. Now, it complains about some other stuff, but if we scroll up, we'll notice it's no longer complaining about, so here's where I recompiled. It's no longer complaining about .begin. It is complaining about the order of my members, which I will fix. So this warning here, this saying this will be initialized after, it's a strange way of framing it, but what it's really complaining about is in the initializer list for your constructor, you decided to initialize the reference and then the index. And when we list the members in the class, they were in the opposite order. The compiler doesn't like that. It would prefer it that you initialize members in your constructor in the same order that they are listed in the class. And so it's complaining here that I had them in the wrong order. Again, actually a very reasonable complaint. So I'll recompile again. And that's one of the reasons I like the compiler telling me this stuff, is that there are reasons why having it in the right order is important, and I like the compiler giving me that warning. Now it's only giving me errors about other stuff. So it's no longer complaining about .begin. I fixed that problem. It's no longer complaining about the order of constructor initialization. I fixed that problem. But it is quite reasonably saying, I'm sorry, iterator objects do not have a star operator. They do not have a plus plus operator. They do not have the minus minus operator. So how am I supposed to use those things? So what I have to do now is define those operators for my iterator objects. All right, so I guess we'll start with the star operator. So the star operator here, where I'm using it in main, the goal is to retrieve the element of the vector at the location the iterator refers to. So here's my iterator. It refers to location 1 in this case. Go retrieve that element. So what I'm retrieving is an int, and I want my iterator to allow me to modify the element. So I'm going to return an int reference. So I do int operator star. What I'm defining is the unary star operator. So it's just star iter. So the operator doesn't take two operands. It takes one operand, which is the iterator. Recall that when I define an operator to be a member of the class, one of the operands is automatically the current object. And in the case of a unary operator, that means that there are no arguments to the operator otherwise. So, okay, if somebody uses the star operator on this iterator, what do they get? Well, I guess we go and grab the corresponding element of the vector. So I'll return my associated vector .at the index stored internally. So the iterator is keeping track of an index that it corresponds to. If you ask the iterator to give me the corresponding element, I'll go into the vector and grab that index. And then what about the plus plus operator? Okay, so the plus plus operator in our cases, we're using the prefix plus plus operator, pre-increment, plus plus iter. We should recall from C that if I use this notation plus plus I, what I'm saying is increment the value of I and then send back the new value of I. So I suppose the plus plus operator should send back something, it shouldn't just return void. But what I'm sending back, just like how if I increment an int, I increment I, an int, and I send back the new value of I, an int. If I increment an iterator, well, what I'm sending back is probably the updated version of that iterator. So I'll return the current object. This is similar to our assignment operators that also return iterator or would return the current object, star this. This will be operator plus plus. And I should make a note here. This is the prefix. This is the pre-increment operator, e.g. plus plus iter. There is different notation you have to use to define iter plus plus, because as we know, there are two distinct plus plus operators, one that goes before, one that goes after. If you want to overload the other plus plus operator, it has to look a little bit different, which is an interesting technical point, but not one that we'll worry about in this video. Okay, so what does it mean to use plus plus on an iterator? Well, I guess for now, we're not yet worried about how the iterator becomes invalid. For now, we're just worried about valid things I can do with the iterator. For now, when I use plus plus on an iterator, what I'm saying is position yourself at the next index of the vector. So something like this. So in other words, what I want to do is increment the internally stored index for the iterator. And similarly, for the minus minus operator, so the operator minus minus, this would be the pre-decrement operator. Again, all of these are unary operators. They take just one operand, which is the iterator itself, which is why we see no arguments being passed in when we write the signature for the operator. When I do operator minus minus, I should expect that I decrement the internally stored index. If the iterator points at 17 and I decrement the iterator, the index stored internally will now be the index of 10. And obviously, you're staring at all this and saying, why don't I just use indices on the vector to begin with? The reason is because there are lots of contexts where iterators are a nice abstraction. They're clunky to use, but it's nice that on a list or a map or a vector, I can use the same notation to iterate over it. And again, our end goal is for each loops. I want to be able to write for each loops over my vector. Whether I like iterators or not, you need iterators to write for each loops. Okay, so I now have plus plus and minus minus. Let's see whether the compiler's ready to let me get away with it. It is complaining, and I think the complaint is reasonable. It's another thing that I forgot to return. So my plus plus operator is supposed to return the iterator itself on the logic that I might write something weird like auto iter2 equals plus plus iter1. Right? So I increment the iterator and I send back the new value of the iterator. So in other words, I just send back the iterator itself. So I do star this. And then same thing here, return star this. All right, so we'll try that. We'll see whether that compiles. And it looks like it did. I'm also going to clean up the screen a little bit. So here, the compiler is now saying, okay, I'm satisfied. You now have this special object that represents an iterator over the vector. I have the ability to increment it with the pre-increment operator plus plus and decrement it with minus minus. I have the star operator that I can use to retrieve the element. And finally, I have this begin function that creates and returns an iterator. So we'll go down to main, hope for the best, cross our fingers, and try running it. There we go. Whoops, that's a version I was working on earlier. Raw vector iterator 1. So reading elements with raw iterators, that's the first step. And so we've got iter1, which is created with v.begin. We can actually track through what iter1 is supposed to do. So iter1 is created, and it begins by pointing at the very first element of v, index 0. Then we print out the first element, which is 6. We increment the iterator, so now it should point to the 10. And sure enough, it does. We increment it again, so now it points to the 17, and it does. We use the minus minus operator to pull it back by 1, and it then points to the 10. That looks good. And then down here, we try modifying the elements of my vector with iterators. I suppose that I should try printing the vector out or something after this. We'll just add a quick for loop to print it out. We don't yet have for each loops, so we'll use unsigned int I starts at 0, I is less than v2.size, I plus plus. Between videos, I managed to delete this loop from the template, and then we'll just print out the elements of v2. So v2.at_i. And then we'll print a new line at the end. And then I will redraw my diagram to reflect, first we'll recompile, and I'll redraw my diagram to reflect the values of v2. Okay, so let's see, our vector v2 here is initialized to contain, initializes to contain 187, 111, 116, and 445. Okay, and I create a new iterator that begins by pointing to the first element of v2, and that is happening down on line number 158. The very first thing I do is I move the iterator along. So I move my iterator now to point at the element that is currently 111. And then I use the star operator to modify the element. We saw above, the star operator returns a reference to the element, so doing this modification is valid. And it should set the element that was previously 111 to be 999. Then we move the iterator along by 1 again. And now it points at the number 116. We set that element to be -1. And then we print the vector out with this quick loop that I cobbled together, and we can see what gets printed is indeed what we expect. So the iterators that we've produced, we're able to create the iterator pointing at some index of the vector. We always create pointing at index 0 with .begin. We can move the iterator along, we can read elements, we can modify elements, and those modifications stick. You could also verify, if you take a look at the posted code, that you could make multiple iterators into the same vector, and those iterators are indeed independent. There's no worry about two different iterators somehow colliding with each other. There is the usual problem with vectors of if the vector resizes, if you make any modifications to it, you might end up with iterators that are invalid, but we're used to that. We're used to iterators being sort of disposable. We use them for a task and then we're done with them. At the moment, our iterators do function for these examples exactly like iterators over an actual vector. What remains is to add the actual iteration logic. So it's not just can I create the iterator, can I increment it? It's also questions like what does v2.end return? How do I test if an iterator is equal or not equal to another iterator? We'll talk about that in the next video.